Welcome to A-Star Science. This is part of our GCSE Must Know Chemistry series. Today we're going to be talking about testing for gases and ions. Testing for gases and ions forms part of qualitative chemistry. Qualitative means testing for the identity of a substance, whereas quantitative chemistry is about the amount of a substance. And so today we're going to be focusing on qualitative chemistry rather than quantitative. Quantitative is when we looked at moles, looked at limiting reagents, and things along those lines. So qualitative testing, a major part of it is testing for the different gases and ions. Some of this you only need to know for foundation, but there's much more that you need to know for those of you that do separate science, separate chemistry, and I will make the distinction in this video. First, let's look at the testing for the common gases. And number one being hydrogen. In this case, you can test, the test is commonly called the squeaky pop test. Many people will know this test. And what this involves is that hydrogen will cause a lit splint. A splint is just a thin piece of wood to ignite with a pop sound. Now, it does that because hydrogen is very flammable. So when you put the lit splint next to it, it forms basically a mini explosion, really tiny explosion. The gas expands quite quickly, and that gives the pop sound. So the next test is similar. It's the test for oxygen gas. And this will cause a glowing splint, meaning a splint that was burning but is no longer burning with a flame, it's just glowing. That glowing splint will relight. So a new flame will appear. Most of us know that flames and fire needs oxygen as part of the fire triangle. So when you expose it to gaseous oxygen, the glowing splint will relight. The third test that you need to know is the test for chlorine gases. Remember, all of these are tests for some common gases, and we're going to use damp blue litmus paper. Litmus paper is just a pH paper. You have blue and red. Damp blue litmus paper will turn red, then bleach white in the presence of chlorine. This is because chlorine is an acidic gas, so that blue litmus paper in the presence of an acid will turn red, then bleach white. The white comes because chlorine is a very good oxidizer. In fact, it's used in many of the products we use to whiten our clothes. The next test is the test for carbon dioxide gas. So in this test, we're going to use lime water, which is just aqueous calcium hydroxide. And if the lime water turns cloudy, by the way, we have to bubble the gas through. If it turns cloudy, meaning it forms a white precipitate. Now, a precipitate is just a solid substance that forms in a otherwise clear or colorless liquid. So in this case, if the lime water turns cloudy, forms a white precipitate, we know that is the positive test for carbon dioxide. Now, these are the main gases, testing for gases that you need to know for the foundation paper. The tests that we're going to talk about now are tests that you only need to know for separate science. However, before I do that, there is one more test, actually. One more test. This isn't a test for gases, but this test does come up in the organic side of your topic, and that is the test for bromine. And in fact, it's not the test for bromine, it's the test for alkenes. Now, alkenes are your organic molecules that have a double bond like that. And so you can test for these alkenes by using bromine water. So if you add bromine water to any alkene, bromine water is normally orange. If it turns colorless, you know that an alkene is present. Okay? So bromine water will turn colorless in the presence of an alkene. So these are the 5 tests that you need to know for foundation. The rest of the tests that we're going to discuss are for separate science only. So these tests we're going to look at are now for the separate science only, and we're going to break it up into a few different categories. The first one is the testing for anions, common anions. Now, anions, we remember, are negatively charged ions, basically. So anions are negatively charged ions, and we can test for these. In particular, we're going to test for the halides. Halides come from group 7, the halogens, and they are the ions of group 7. So for example, chloride. The test for chloride is we're going to add a solution of acidified silver nitrate. It has to be acidified because the acid ensures that there's no impurities that could give a false result. And if chloride is present, a white precipitate will form. Remember, we said that a precipitate is a forming of a solid and a liquid. We can do the same thing at acidified silver nitrate. And if bromide is present, remember, we're not talking about bromine or chlorine, we're talking about chloride and bromide. If bromide is present, an off-white precipitate will form. And they can be quite similar. And so in A-level chemistry, we learn how to distinguish between the two with ammonia. But in this case, for GCSE, you just need to know what the main test is. We can also see if iodide is present, and that will form a yellow precipitate. Okay, so we can test for the identity of these ions, these anions, in a solution if they are present by using acidified silver nitrate. Let's look at some other anions as well. We can test for sulfates, SO42 minus, which is a sulfate anion. And if we add barium chloride, okay, if we add barium chloride to any substance that we think contains a sulfate and a white precipitate forms, that is a positive test for sulfate. That's because barium sulfate is an insoluble precipitate. So by adding barium chloride, we can determine if, by adding barium chloride, we can determine if a sulfate is present. So those are the main anions, meaning the negative ions that we can test for. Let's look at testing for some of the main cations that you need to know about for separate science. Now let's look at the test for the different cations, the metal ions. Cations are positive ions, and metal ions, when they're in aqueous form, will form these positive metal ions. And in this case, we're going to first talk about the flame test. Literally, you can take a wire and dip it in a solution with these particular ions, and then you can see the different colors that may form from their flames. So for example, lithium plus ion, that's going to give a crimson color flame. Crimson is like a bright orangey sort of flame color. Sodium plus that's going to give a yellowish flame, which can be a bit hard to distinguish between just a normal flame. Potassium, though, that's going to give a nice purple lilac color. So that's a nice one to look at. Easy to distinguish. Potassium. Calcium, which is a 2+ ion, that gives more of an orange-red color. So that also can be a bit hard to distinguish from just a normal flame. But one of the most clearest one is the copper, which gives a nice green color, a green flame. And so that's quite easy to distinguish between them. One of the tests, one of the questions they like to ask in the exam is what one of the disadvantages of these tests are. And one of the disadvantages is that the flame colors, if the substances are mixed, the flame colors will also be mixed. And so it can be hard to distinguish between the presence of the different ions because they will mix and give a different range or spectrum of colors. So let's continue to look at how then we can use testing to distinguish for the different cations. So another way that you can use besides the flame test is by using a substance called sodium hydroxide. So if you add sodium hydroxide to the different ions, you will get different precipitates form. So for example, if you add sodium hydroxide to calcium or to magnesium and to aluminium, they all form a white precipitate. So this can be helpful because we said that the calcium gives a specific color flame. And so if it also gives a white precipitate, then that's a positive test. You can distinguish between the two by using excess sodium hydroxide, and that will dissolve the white precipitate if aluminium is present. It won't do that for calcium and magnesium. Again, if you add sodium hydroxide and copper 2+ is present, you're going to get a beautiful blue precipitate. And so that's going to be quite clear to know if copper was present in that particular solution by adding sodium hydroxide. Iron 2+, that's going to give a green precipitate. Now there are two types of iron ions. Iron 3+ will give a brown sort of rust color precipitate, so brownish orange. And so these are some other tests, additional tests that you can use along or alongside the flame tests to help distinguish between the different cations. Testing for ions, testing for gases is really important in chemistry and can be used in many industries such as forensic science, environmental science. So this is really important that you need to know these tests. Please make sure you like and subscribe. Add a comment below and let me know what videos that you'd like me to do, and I'll be happy to do one for you.